Ni hao. We share Pablo Araujo from Ecuador, Central University, Universidad Central del Ecuador. I teach in organic chemistry in the chemical engineering faculty. But today I will not speak about organic chemistry. Today I will speak about Antarctica, the South Pole, and how the nutrients distribution and the oceanographic parameters is in the Horseshoe Island. So this research work is not possible without all these great collaborators. The Faculty of Science of my university. These guys love create numbers, models, statistics, experimental designs. La Dirección General de Intereses Marítimos, DGIN. This is the Navy of Ecuador. Without the Navy support, the scientists, we cannot go to Antarctica. The military, the Navy opened the door of Antarctica for the scientists. And the Chemical Oceanographic Unit from the Liège University in Belgium. So my presentation has 4 perfect points. The first one is, why Antarctica? Why a chemical engineering go to Antarctica to take samples from the sea in this unique place of the world? The second one is the ocean's foods, the key nutrients, and what is the water status and the water quality in Antarctica or in Horseshoe Islands. So I continue with how we collect and how we analyze the samples and the results, the first result of these Antarctic expeditions. So Antarctica is very sensitive to the climate change. The climate change is a stress. It's very important for us to think that Antarctica is the world's refrigerator. So let's try to understand what happened in our house if the refrigerator, the fridge, is under stress. Something sometimes works, sometimes not. See? And in Horseshoe Island is a very special place because the island is surrounded, as all of Antarctica, by glaciers. In this part, you can see the end of the South America. And from here, from Punta Arenas, Chile, all of the scientific Antarctic expedition starts. You have 2 ways to cross this part of sea. This part of sea is called Drake Pass. It's a very difficult ocean to sail in, but you have 2 ways. The first one is to take a plane here in Punta Arenas and go to this island, very small. It's called King George. The flight takes 2 hours if the weather conditions are good. The other way is take a ship here and navigate if the weather conditions are good for between 4 or 5 days, or not navigate. You have to wait here in Cape Horn until the conditions are good. In this time, the expedition was in February 2023, and I have the lucky. I was a lucky chemical engineer because I took the plane and fly to King George Island. In the next expedition, I hope the next year, maybe, I show the results. I navigate the Drake Pass. So when you get a King George Island, you have to move for this strait, Gerlache Strait, and Bransfield Pass to get this purple point in my presentation. This is Horseshoe Island. Look how beautiful is Horseshoe Island in February. This is in summertime. So look at the glaciers, look at the mountains. They are amazing. But the climate change that I said is stressed. So when the glaciers break, you hear as a thunder. And this part of ice glaciers broke down and melt and convert an iceberg. So this is the reason because we go to the Horseshoe Island, and in this part you could find the scientific research camp from Turkey. So this project you have we collaborate with an international scientific efforts. Thank you very much for my colleagues in Turkey, scientists, because they opened the gates of his research camp to do this. So let's start. What is to convert the ocean as a life organism? The nutrients. Basically, the nutrients like molecules as a nitrate, as a phosphate. This is the basic molecules in the chains. If these molecules don't appear or destroyed in the environment, no krill, no whales, no penguins, no tuna, nothing in the sea. And the first one is the phytoplankton. Great. This is the HorseShoe Island, our drawings. We take the samples from all of the coast, taking into account in this part of the coast, the glaciers melt and break down to the sea. And we create these lines inside of the bay because when especially from this one, when these glaciers break down, all of the icebergs from the currents, marine currents, flow to here. Okay. As I said, we collect 24 stations at deep meters deep. This deep is very important because at 10 meters deep, you could find a lot of process between the atmosphere and the water in the ocean, especially when the lies inside the sea. You can find a lot of concentration of chlorophyll and so on. Perfect. We use an iskin bottle and we deploy the iskin bottle from a small boat 10 meters deep. Perfect. So after we collect the samples, these samples is from the analyzed methane and nitrous oxide because our interest is not only nitrate and the nutrients in the sea and the water quality, also is the greenhouse gases. But today my speech is only about nutrients. Perfect. We measure also the total suspended matter in the water for sure conductivity and salinity and sea surface temperature. We follow very strict protocols from our colleagues in Belgium. So results. This is the total suspended matter heat maps. Please be careful to the scale. In this part, we found more than 2,000 milligrams per liter. If you compare this one to the clean water in your bottles, is 2,000 more. This is the conductivity. If the glaciers melt, the conductivity is low because it's fresh water that comes to the sea. At this point, in yellow is the normal conductivity from the sea, but you can see is an open sea. But when the glaciers melt, you could say the conductivities change. So this is a table from results. Please take a look at the total suspended matter. This is the maximum value. It's like a soup, a black soup in the water. This is nitrate concentration. This is phosphate concentration. Please take a look in the value of the phosphate concentration. See? This is the heat map for phosphates. What is the source of these phosphates? We think that when the glaciers melt, as a big food of the giants over the rocks, and this increase the concentration of phosphate in the water. After that, this part is normally the water has these ones from 1 to 2 concentration of phosphate, but in this part you can see it's 5 times greater. This is the heat map for nitrate. It's okay for the values. The normal sea ocean has a 2 values, but it's okay. But it's interesting when you go. When you go far from the glaciers, is lower. This is one key factor because the denitrification process on water, it works if you only see the nitrate. But if you put the greenhouse gas nitrous oxide close to this heat map, you can see that in these parts, arise the nitrous oxide from the water. So we think that is some problem in the denitrification route in this part. This is the seawater temperature. It's very interesting because when the glaciers melts, it's colder. 0 or minus 0. And in the open waters, this is hot. It's 1.5 Celsius degrees, the water. So if the glaciers melts, yeah, for finalizing, my time is over. The water is colder for sure. Is ice in the water. Is less salty, and there is a more turbidity. Okay? This is the baseline. Every year from Ecuador, we start the Antarctic expeditions with different colleagues from different universities, and we are going. Our project, I hope, is for 10 years and ahead, and every year we can collect the data. Sincerely, thank you very much for joining me. Thank you very much for inviting me to this session, and it's very nice for us to collaborate with you. If one of you are interested in work with us in Antarctic subjects, you are welcome. Thank you very much. Thank you.
So, thank you very much for nice talk and contribution.
Sí, sí. Oh, thank you very much. Perfect.
Okay.
Thank you very much.